Hello, everyone. Greetings from Florida. Today, we're going to spend some time talking about data and fleet management. Before we get started, I want to provide a little context on Geotab. We have over 2.1 million connected fleet vehicles around the world. Each day, those vehicles drive over 100 million miles, and all that driving means a lot of data. Every day, we add 40 billion data points to our big data warehouse, which I will talk about a little later. I deliberately took the term telematics out of the session title because I don't think of what we do at Geotab as strictly telematics. We are a data enablement provider. We collect both the vehicle and driver data from customers' vehicles, send it to our cloud platform where it is normalized, and then provide all that data in one user interface that allows the customer to run their business more efficiently. I also think in these value tiers of data, starting with fleet productivity, which includes the things you typically think of when you think of telematics. But then we move into data-enabled insights, where you use data to solve maintenance problems, create driver scorecards, and take a look at ways to reduce risk. Then we have what I call data for the public good, which I'll also get into a little bit later. Finally, data is a real enabler when it comes to new mobility initiatives such as car sharing, ride sharing, and public-private partnerships such as smart city development. So why do fleet customers want telematics? It varies based on the business, but in my experience, it falls into three primary buckets: improve driver safety and reduce risk, increase productivity, and improve operational efficiency. Not that sustainability and compliance aren't important, they just don't seem to be the primary drivers for most businesses. Now I'm going to introduce what might be a new term for some of you, COI. What is it? It's the actual dollar savings that you are not realizing by not taking action. COI can be thought of as the incremental costs that result when a fleet decides not to deploy a telematics solution that would otherwise reduce these costs around fuel, maintenance, and how drivers operate their vehicles. The same reasons most fleet want telematics, it's just that they don't think of it in these terms. Now, you're all familiar with ROI, return on investment. I like to use COI when selling the benefits of telematics. The goal of both is the same, to increase profits, but with COI, the focus is on minimizing operating costs. So the questions business leaders ask is different. Instead of how should we spend our cash, it's where can we save money by being more efficient, more productive, and reducing risk. How much money can paying attention to the data that is at your fingertips save you every month? And how much more could you save? Items like fuel economy improvement, reduce maintenance costs, reduce miles driven, overtime based on work hours and time cards, and improve safety and reduced accidents are all huge savings opportunities. Orkin Pest Control operates over 10,000 vehicles around the US. Several years ago, they had a serious problem. They were having to set aside 8% of their annual revenues to pay accident claims and liability costs. The CFO quickly realized this was not sustainable, and it put the company in financial jeopardy. They implemented a comprehensive driver and vehicle safety program, the components of which you can see on the slide. But one of the more innovative policies that was put in place was one that prohibited driving in reverse. Backing out of a parking spot, especially when in a hurry, can be a dangerous activity since other vehicles and pedestrians tend to be nearby and in motion. Surprisingly, it has been estimated that approximately 30% of all accidents occur when vehicles are moving in reverse. It is recommended that drivers do not back up unless it is absolutely necessary. There are many hazards to consider when reversing out of a parking spot, including the clearance space surrounding the vehicle, moving objects, and blind spots. With telematics technology, employers can set up the hardware to alert the driver when they are in reverse or backing up. They can set notification rules in the software in order to be informed when these events happen, either by text message alerts, email alerts, or screen pop-ups. You can also look at historic data to see whenever and wherever drivers went in reverse. Built-in fleet management technology detects reversing of a vehicle regardless of diagnostic computer data. This is done with the use of the accelerometer and algorithms to detect what direction the vehicle is going in. The result of implementing this program saved Orkin $28 million year over year. Telematics can help monitor seatbelt usage. Fleet managers and supervisors may be surprised to find out how often their drivers aren't wearing a seatbelt. According to the most recent seatbelt survey data from the FMCSA, about 85% of commercial drivers regularly wear a seatbelt. That means that 15% aren't. But perhaps the most startling statistic is how much seatbelt use or lack thereof can affect the cost of an accident. The network of employers for traffic safety, NETS, stated that not wearing a seatbelt cost employers $4.9 billion in relation to accidents. To help reduce incidents, telematics can send alerts to managers and/or drivers when drivers aren't wearing a seatbelt, the rules of which can be customized by the fleet, such as only if it's in certain areas, i.e. inside geofences or at certain speeds. Seatbelt information is crucial to many of Geotab's customers. However, it's not always as easy to retrieve as its physical simplicity may imply. Seatbelt data is not mandated by OBD2 specifications. This means that different vehicle models, makes, and years can all report seatbelt data differently. Because of this, Geotab goes the extra mile to obtain seatbelt information. Geotab's Go device employs a complex detection and verification algorithm to combat these difficulties in order to cater for as many vehicles as possible. The Go device will report data it believes is seatbelt data, but only when a piece of data passes the verification process will Geotab start reporting seatbelt. Fleets can use telematics data to improve productivity in a number of ways. You can accurately predict when a service tech will get to a customer's location and keep the customer up to date on the expected arrival time based on current traffic and weather conditions. You can identify unexpected stops. Is a driver going 20 minutes out of the way just to visit his favorite lunch spot? You can improve customer service times by measuring when a service tech arrives at a customer location and when he or she leaves, and benchmark that against what it should take to complete the job. You can get true trip miles that can be used for billing customers if that's part of your invoicing process. Businesses that own or operate commercial vehicles must think about properly maintaining their entire fleet while also being proactive with driver safety. Fleet management technology can help businesses do much more than track vehicles on a map. One of the central and useful functions is scheduling maintenance reminders and checking vehicle health in real time. Automating these processes removes some of the uncertainties that fleet managers face on a daily basis. When deliveries of new vehicles are delayed, preventative maintenance is critical to extending the health and life cycle of existing fleet vehicles. When current vehicles being kept in service for longer periods or kept in prime condition to be repurposed for other business opportunities, increasing communication around maintenance should remain a top priority. For fleets that are not part of a fleet management service company, The reminder rule is a great way to help stay on top of maintenance. This highly customizable free rule can be built off of any combination of time, engine hours, or mileage, any of which can trigger an alert. Once a notification is triggered and new maintenance is entered, all three counters automatically reset. The cost of ignoring maintenance events will always be much greater than the cost of acknowledging them. So addressing these events in a timely fashion is a must. Taking preventive measures to eliminate the possibility of maintenance problems down the road will invariably pay off for a fleet in uptime and dollars saved. A maintenance reminder feature can greatly help with this process. Cost containment is critical in uncertain times. Having a system in place to warn fleet managers about potential issues allows fleet managers to take proactive steps towards resolution. Fleets can use built-in reminders or create custom ones specific to their duty cycle. Things like engine light on. This rule identifies vehicles that are driving with a check engine light on and can be used to schedule maintenance or prevent serious issues. The average time to clear a check engine light is 90 days. That means 90 days of performance that could have been optimized. Another one is battery drain. This detects vehicles that have a battery voltage below 9 volts. Alerts from this rule can help identify general battery problems or remind drivers to turn off their vehicle lights. Helping drivers avoid a dead battery also helps prevent missed service calls, loss of work time, and tow truck bills. I'll talk more about that in a minute. Reporting on fault codes is useful for troubleshooting and understanding the severity of vehicle issues. These reports are dashboard ready and can be emailed daily or weekly. What we're looking at here is an engine fault report. This report identifies vehicle-based faults from the engine control module and provides the controller and diagnostic code. Customers can also set up notifications for the fleet mechanic, fleet management company, or their local service repair shop, all of whom can act on this information. Active diagnostic faults and other engine-derived information available through fleet management software can be used to prioritize those vehicles in need of maintenance. Quickly identify core problem areas and reduce maintenance costs by focusing on predictive engine health. By managing your engine fault code information, you can proactively attend to engine issues early before they turn into costly repairs or vehicle downtime. These vehicle codes quickly identify and locate the engine issue, helping you save on vehicle inspection time and costs. Today's technology is helping fleets minimize downtime. Fleet managers can now detect vehicle faults before they become a more dangerous and costly problem. Some solutions, like Uptake's Asset I/O, deliver predictive maintenance insights from existing vehicle data. Asset I/O applies over 140 artificial intelligence machine learning models on raw sensor data accessed through Geotab telematics. Urgent insights are sent to fleet managers, while non-urgent insights are sent to work order management systems. Other tools pair advanced technology with human experts to achieve quick resolution. For example, IntelliConnect Remote Diagnostics from Eaton provides near real-time monitoring of vehicle fault codes. By integrating telematics data and Eaton data, on-hand technical experts prepare comprehensive action plans, prioritizing critical events. So what are the pros and cons of maintenance reminders? Well, for the pros, it's always being in the know. Receive regular friendly reminders either through email or text to be alerted when a vehicle is almost due for a maintenance event. This helps actively prevent maintenance issues from affecting a fleet's operations and eliminate the possibility of unprecedented costly vehicle problems down the road. Another one is increasing the lifespan of your fleet. Healthier vehicles lead to greater productivity. Vehicle downtime directly affects a vehicle's ability to generate revenue. Eliminating unnecessary downtime will help a company maximize its revenue stemming from the fleet. Another pro is predictive maintenance scheduling. Receiving early maintenance reminders can help efficiently schedule necessary vehicle downtime to perform maintenance events and/or vehicle repairs. Staying organized. Organize past maintenance events to keep track of your fleet's maintenance history. This helps identify vehicle trends, which further complement the preventative measures a fleet is taking. So what are the cons of maintenance reminders? Well, I can't think of any. This is an interesting example of how real-time data combined with machine learning can solve complex maintenance issues. One of our customers was having a problem with drivers heading out to their vehicles in the morning to make their daily deliveries, only to find a dead battery. This caused delayed or missed customer deliveries. The problem was so bad that the company would replace all batteries every 3 months just to avoid the risk of a truck not starting. You can imagine how much of that costs for a fleet that had tens of thousands of vehicles. So they asked if we could help. Our data science team took a look at the last cranking voltage of vehicles that had failed batteries and matched that up with the reading of the ambient air temperature when the vehicle did not start. They then applied some machine learning algorithms and were able to come up with data that can predict within a 2-week time frame when a battery is going to fail with 80% accuracy. Needless to say, the customer was ecstatic. But the data science team thought they could do better. They went back and they added one more parameter to the algorithm: oil temperature in the crankcase. Now, if you've ever tried to start your car on a very cold morning, you know it can struggle to crank over because that cold oil is very thick and requires more cranking power to get the parts moving. By adding in the oil temperature parameter, the predictive failure accuracy rate climbed to 95%. Earlier, I talked about using data for the public good. I want to show you some examples of what that means. In January, Geotab debuted a new tool called Ignition, which is data collected from over 2 million connected commercial vehicles that has been cleaned, aggregated, and anonymized into insightful data sets. Ignition is a tool that acts as an interface to explore, interact with these data sets, run queries against them, and also visualize them on the map. Data is organized into 3 major categories: urban infrastructure, location analytics, and weather. A 4th category was recently added that looks at the impact COVID has had on the transportation system. We make this data available to customers at no charge. Companies can use Ignition data and add in their own internal data to create even more useful insights relevant to their business. Here's an example of an urban infrastructure data set looking at intersections. In this example, all left turns were aggregated at the intersection level by hour of day to show the average wait time for left turns throughout the city. A red dot means a wait of a minute or more, while a blue or green dot means a wait of less than 10 seconds. If we combine metrics like average idle time and average wait times throughout the city from this data with volume and emissions estimates, we can also start to evaluate the impact of idling on greenhouse gas emissions at an intersection level, then incorporate an environmental analysis for infrastructure project prioritization. This data becomes particularly interesting at the individual intersection level when you can begin to see the impact of things like rush hour congestion, dedicated right and left turn lanes, nearby shopping centers, and other factors. This data is organized by weekday or weekend, hour of day, and type of travel through the intersection for every intersection with a traffic signal in the city. Example use cases for individual intersection data include pinpointing times when congestion is most problematic, see how congestion may have a chain effect through a corridor or area of the city, gain insight to inform light timing changes, and identify where a dedicated turn lane is needed. Every Geotab device since 2010 has featured a 3-axis accelerometer, capturing measurements in the forward, back, or x-axis, left, right, or y-axis, and up, down, or z-axis direction. The forward, back, and left, right axis data are critical components to measuring and improving fleet safety since they are highly correlated to driving behavior. With ignition.geotab.com, we use this same XY axis data to identify and score hazardous driving areas. Unlike the XY axis data, the Z axis is not a function of driving behavior, but rather a measure of the overall smoothness of the vehicle while in motion. Z axis variations are indications of abnormalities in the driving surface, including potholes, speed bumps, temporary obstructions, and general road surface issues. The goal of Geotab's road impediments dataset is to leverage the Z-axis data to identify and score the smoothness of the roads traveled by each of our 2.1 million devices. Using geohashes, the globe is divided into 40-meter by 20-meter boxes, and variations in the Z-axis activity are captured in aggregate, providing a measurement of the average acceleration felt and the percentage of vehicles that experienced a disturbance while traveling through each geohash. The dataset also includes traffic information for each location, which contains the average number of vehicles traveling through the geohash and a breakdown of the types of vehicles observed. Essentially, we can provide most cities in the world with a map of where every pothole is located. And we have done that for some, where the data has been turned over to the Public Works Department to initiate repairs. Here are some examples of the valuable insights available to cities when you combine sensor data with anonymized big data and artificial intelligence. Roadside weather. Gain insight into hyperlocal roadside weather conditions on all major roadways. This is actually an interactive tool. You can see that you can adjust the temperature, visibility, precipitation, and traffic density to create predictive models of the impact of weather on road conditions. You can identify potential black ice conditions or high temperature areas that could lead to concrete buckling or cracking. Even proactively notify your citizens of dangerous road conditions in near real time. Imagine you were the Public Works Director for the city of Chicago, and you have this tool as you prepare for a snowstorm. You would know which roads were going to ice over and which ones won't based on temperature, precipitation, and traffic volume. That allows you to only send snowplows and salt trucks to those roads that are going to need it. Talk about fleet optimization. Of course, none of what we're talking about is possible if you can't access the data from the vehicle. Whereas 10 years ago, you might see a fleet make a vehicle purchase decision on whether it came standard with ABS brakes or not, we are now seeing fleets telling OEMs that if they can't get seatbelt data from a vehicle, they will not buy it. To that end, Geotab has created a Vehicle Data Accessibility Index. We identify by OEM, make, and model which vehicles provide good accessibility to data and which do not. This index is designed to bring reliable information, analytic rigor, and transparency to the data access debate. This will help all stakeholders. The goal is to foster fact, evidence-based understanding, informed choice, and accountability in the transportation and infrastructure sectors. The approach is highly collaborative. All stakeholders, especially vehicle OEMs, are invited to comment on and critique the approach and participate in its further development. Now, we started simple with 4 key metrics: VIN data, true odometer reading, fuel code support, and seatbelt data. What you see on this chart is the score of 18 OEMs. I hid the names to protect the guilty. The x-axis measures % of vehicles with full data support. The y-axis looks at the consistency of data across all models. The dots in the upper right are OEMs that do a good job of providing all 4 key data sets across all models in their lineup. To conclude, with over 40 billion data points collected every day, we think of vehicles as sensors on wheels that help us unlock a suite of intelligence data about our world. True intelligence data can only be gained from leveraging large and rich volumes of data from various sources, and telematics data can help achieve this goal. Now, there's a common misconception that only GPS data is captured from telematics, but now you know nothing could be further from the truth. At Geotab, we capture a vehicle's location, speed, accelerometer data, and a wealth of data from a vehicle's computer, including seatbelt usage, detailed engine diagnostics, and more. All of this data at scale yields a wealth of intelligence that can be factored into how a business runs its operations, but also to improve the transportation ecosystem for all of us. Thank you very much.